Did you know that one loss of control accident occurs every 4 days in the US? Loss of control in flight, referred to in the industry as LOC-I, is the #1 cause of fatalities in general aviation. In this video, we'll explore factors that contribute to these types of events, discuss some risk management tips provided by industry experts, and review features available in Garmin devices that are designed to reduce the risk of loss of control.
LOC-I is defined as an unintended departure from controlled flight. This happens when an aircraft enters a flight regime that is outside of the normal flight envelope, which can lead to a stall or spin. Many times, this involves an element of surprise, followed by an inappropriate application of controls that leads to the departure from controlled flight. Factors that contribute to these events include human performance deficiencies, automation and mode confusion, distraction, the startle effect, scan fixation, and loss of situational awareness. These factors can easily lead to a failure to maintain an appropriate airspeed, failure to recognize a stall or spin, and a failure to apply corrective forces. Many times, the triggering event is weather-related, in the form of turbulence, wind shear, or airframe icing, but could also involve wake turbulence, or an inappropriate response to an abnormal or emergency situation.
LOC-I can occur in any phase of flight, but holds the highest risk when you're close to the ground. Failing to maintain proper airspeed during initial climb out can lead to a stall and subsequent loss of control when there is insufficient altitude for recovery. The same thing is true during approach to a landing. There are many recorded LOC-I events attributed to inappropriate responses to unexpected events. In these cases, the pilot becomes distracted while trying to address the issue and fails to maintain control of the aircraft. For some unexpected events, there's plenty of time to pull out a checklist to work through a problem. But at other times, immediate pilot action is required. Pilot training must include developing appropriate responses to unexpected events, and stress that maintaining control of the aircraft is always the highest priority.
Recommendations from industry experts for reducing the risk of loss of control include: always maintain an awareness of your airspeed. This is one of the most important things to scan during takeoff and approach to landing. Never take off with frost or ice adhering to the airframe. If your airframe is ice contaminated during approach to landing, maintain the configuration and airspeed as required in the airplane flight manual, or use FAA guidance found in AC 91-74B. Review emergency procedures for your aircraft on a regular basis, and fly with an experienced flight instructor while working through a list of simulated in-flight emergencies. This helps to develop appropriate responses. Conduct a pre-takeoff configuration flow to check that everything is set to manage the takeoff and initial climb out. This prevents distractions immediately after takeoff, so you can focus on flying. Conduct a before takeoff briefing that includes your initial altitude, initial heading or fix, flap retraction speeds, airspeed to be maintained during the initial climb to a safe altitude, and your plan in the event of an emergency during takeoff. Conduct a briefing for your approach, including visual approaches. That includes the airspeeds to be maintained at various phases, and especially during final approach. Always be aware of the active and armed flight modes of your autopilot, and be sure to select the appropriate modes for the phase of flight. For example, climbing in a mode that maintains airspeed rather than vertical speed is considered much safer, because the system will work to maintain your selected airspeed, even during downdrafts. Using vertical speed mode during a climb doesn't provide this protection. Take upset recognition and recovery training to reduce the startle factor as you recognize an upset. and so you know exactly what to do to recover to controlled flight. These training programs should point out factors that lead to loss of control and train you to respond effectively.
As with management of other hazards in aviation, there are a number of electronic awareness features in Garmin products that can greatly contribute to reducing loss of control events. These range from angle of attack indicators, approach speed cues, speed bugs, and low speed awareness alerts, to automatic electronic flight envelope protection features.
While great emphasis has traditionally been placed on monitoring airspeed indications to prevent a stall, the thing that really matters is the wing's angle of attack versus the oncoming air. The stalling angle of attack can occur over a wide airspeed range, depending upon wing loading. Garmin integrated flight decks offer an angle of attack indicator that shows the angle of attack on a scale of 0 to 1, with 1.0 being a full stall condition. Color coding on the scale and indicator needle provide a quick reference when determining how close you are to a stall. The approach speed cue is a green circle that appears on the airspeed tape at a point indicating approximately 1.3 times the stall speed, making it an approximate indication of VREF. This indication is derived from data supplied by the angle of attack sensor, and the indication is dynamic, so that it will move on the speed tape as the aircraft is reconfigured for landing. Most operators will designate a speed above this cue to maintain during final approach, such as speed cue plus 10, and then slow to the cue as the aircraft crosses the threshold. You'll find the approach speed cue on select avionics platforms. V-speed reference bugs can also be shown next to the speed tape to assist with managing speeds. These speeds for these bugs can be manually entered, or be the result of calculations made after landing conditions are entered. These aid in maintaining airspeed awareness during approach and landing. The airspeed tape provides additional cues for speed awareness, including an airspeed trend vector that appears in magenta on the right side of the tape. This appears when airspeed is accelerating or decelerating, with the line extending from the current airspeed indication to indicate the rate of change. The end of the line indicates the airspeed that will be reached in 6 seconds if everything remains constant. Keeping an eye on this when changing speeds can help to avoid an underspeed condition. With certain systems, when the airspeed trend vector reaches the red low speed awareness range, you would hear an enunciation of
AIRSPEED.
Automatic electronic flight envelope protection features add yet another layer of safety for protection against departing controlled flight. While hand flying, a feature named ESP, for electronic stability and protection, applies corrective forces to the controls to correct for excessive pitch or roll, and applies pitch up or down forces to keep the aircraft within the normal speed envelope for the aircraft. Some versions of this go even further, and, after a designated amount of time in exceedance of the normal flight envelope, the autopilot will activate and bring your wings level and vertical speed to 0. This is called, appropriately enough, level mode. There have been many instances of stalls occurring while on autopilot. This typically happens when leveling off after a descent, becoming distracted, and forgetting to increase thrust. With underspeed protection, you would see an enunciation of min speed appear above the airspeed tape. You would hear
AIRSPEED.
And when approaching a stall, you would hear
Stall, stall, stall.
continuously, while automatic corrective force is applied to lower the nose to prevent a stall. And while all of these electronic aids to maintaining controlled flight certainly provide the potential to reduce loss of control events, you still need to know when these types of events are likely to occur, how to recognize them, and how to recover from them. Your Garmin team recommends following the recommendations of industry experts so that you can avoid a loss of control event. To learn more about mitigating the risk of LOC-I, see the links provided in the description for this video.
Okay, that wraps up our discussion of ways to reduce the risk of loss of control in flight. Be sure to check out additional information on this subject in the documents that are linked in the description for this video. We encourage you to continue your safety journey by viewing the other videos in the Garmin Aviation Risk Management series. And thanks for flying Garmin.